So dear friends, once again welcome. In the previous videos we have discussed about the range, we have detailed about that. Now let us solve one question, one problem related to the range. Okay, so the problem statement is does reduce the following to a range. So what is following here? So it is the coordinate system. This is the x-axis, y and z. There is a resultant force and there is a here resultant couple. Okay, so R is what? Resultant force, and CR is what? The resultant couple. Okay, and it is given 3I plus 4J plus 5K Newton. Okay, and what about this? It is given minus 2I plus 3J 4K Newton meter, and these are vectors. Okay, and it is what? Then the figure equivalent resultant of, you can say, the general force system. Okay, and this is the origin. Now our task is to reduce the following to a range. So already we have discussed if R and the resultant couple are not orthogonal. So what we get then? So reduction of force system makes a range. Okay, so in the previous video we have seen how then CR is divided into two parts. One is parallel to the resultant, which we denote by C parallel, and one is perpendicular to the resultant. So in this way, already we have seen that video. You can see as a reference. Okay, that is given in the description box. The link is given. Okay, so now then what we did to make a range, this is nullified, and in place of that the equal and opposite forces are added from origin O. Okay, then that is converted into the moment in the couple form. Okay, now let us do this question. So what is the approach? So approach is, firstly, what we get. So C parallel, how to get this? So this can be got by CR, and it's a multiplication of E bar there, and this is what? The unit vector. Okay, and this is what? So this is the resultant. CR is the resultant couple. Okay, so it is in the, our focus is right now to get this one, C, the parallel, and these are in the vector form. Okay, so this we get, and this is in the form of scalar component of resultant couple along the direction of resultant R. Okay, and then how to get it in the vector form. So you can write vector component of our C parallel. Okay, so what we do, this can be equal to the C or its vector and multiplied by the unit vector and further multiplied by the unit vector. Or already as we know, this is equal to what? This is equal to C and parallel, the scalar form. Okay, so this can be written C parallel multiplied by the unit vector. Okay, so in this way we can get the vector component of C parallel. Okay, then how to get C perpendicular? So it is obviously given as the resultant couple is given. So from by subtracting that of C parallel, we can get the C perpendicular. Okay. Wow. Now what is the next? So let us. What is the next? So next is to eliminate C perpendicular. Then what are the things left? Then the left are C parallel and the resultant, which makes a range. Okay. So what we do? So let's move the resultant R to a new position. Say X, Y and 0, such that C perpendicular gets eliminated. Okay. So and why only X, Y, why not Z? Okay. So there is one condition. What is that? So that is the C perpendicular can be replaced by sliding the resultant force along the perpendicular to the plane of the resultant force and a resultant couple. Okay, so we can refer here the figure. Okay, so perpendicular of R will be where? So perpendicular and R lies in where it lies. So it lies, we can see the Y and the Z plane. So what will be the perpendicular? The perpendicular of this R plane. So perpendicular will be obviously the X. Okay, and what about the perpendicular of this CR? So it lies. So what about suppose once again R perpendicular which axis? R perpendicular will be which axis? So X axis. Okay, what about CR resultant couples perpendicular distance? So it lies in which plane? X and Z. Okay, so इसका perpendicular कौन सा होगा? The perpendicular of this will be perpendicular of the CR plane will be Y axis. Okay, that's why here only the X and the Y coordinates are given and the Z is here 0. Okay, so what is the next then? Then what we have to do, C perpendicular, that is equal to the position vector. Suppose R, we take position vector and the cross product of the resultant. Okay, so that is equal to what? And what is the coordinate of this R? This coordinate is X, Y, 0. These are the coordinates. Okay, and somewhere from the 0x. 0 means from the origin. Okay, so this can be written I j k and x y 0. And what about the r from the resultant? There is a, you can see here from the resultant what is, so it is 3i 4j and a 5k. So 3 4 and a 5. So in this way. Okay, and what about c perpendicular? What we get, we have to equate with the, suppose I coefficient of this part, and what we get equation from this, we have to equate. Then what we will get, x and y coordinates. Okay, and what we get, it is minus 1 at 0 meter and minus 712 meter. Okay, so in this way, what we are, then we are left with the resultant and C parallel through this point. Okay. Okay, so let us solve. These are the procedures I have told, but ultimately we need to solve. But how to solve, and what are the things, and what are the things are related to each other? So these are described. So from here, starting with the scalar component. Okay, so scalar component, how to get it? So from here we can get that the scalar component. This is equal to what? So this is equal to, and before that, E is equal to E. This is, yeah, the unit vector, and it is equal to what? So it is the, you can say the resultant, and it's a magnitude. So this is 3i plus 4j 5k divided by, it is 9 16 plus 25. So it is equal to 3i plus 4j plus 5k divided by under root of 50. Okay, then coming to this part. Okay, so this part, it is the multiplication of what? CR. Okay, and what is CR? So once again I am writing this. C parallel we have to get. Okay, and so it is a scalar, so this we have to remove. Yeah, let me do it. So as it is a scalar, so this the bar I have to remove. Okay, so this is equal to what? So it is equal to CR vector and multiplied by the unit vector, and is equal to what we get? CR is given minus 2i plus 3j plus 4k, and it is multiplied by the unit vector. So it is 3i 4j 5k divided by under root 50. Okay, so in this way, let us separate it. Okay, so what we get from this, ultimately we get from here, we get 2 is multiplied by 3, so it is minus 6 plus 12, 3 is multiplied by 4, and then 4 is multiplied by 5, so it is 20 divided by under root of 50, and it is equal to 3.677 Newton meter. Okay, so the scalar form we got means the magnitude of the parallel component of the resultant we got. What about the vector? So it is given here. You can see in the vector form. From here we can take from here, yeah, this one. So in the vector form we are going to write C and parallel component of the resultant couple, so it is equal to C parallel and multiplied by the unit vector. Okay, so it is already what we got. This is equal to C, this is equal to this actually. So 3.677, and again the unit vector we need to write here. So 3i 4j plus 5k divided by 50. So in this way. Now what is the next? So next is to get C perpendicular in the vector form. So already we know the couple resultant, so from that we can subtract the parallel component of this resultant. So this is equal to, let us separate it to avoid any confusion. Okay, so it is minus 2i plus 3j plus 4k multiplied by what? Sorry, minus 3i plus 4j plus 5k, and then it will be multiplied by what? Because there is a this divided by this, so it is multiplied by 0.5185. Okay, so what we get from here? We get minus 3.56i, then 0.92 j plus 1.4 k. Okay, okay, so what is the next? This I have already explained. Our purpose is to eliminate, to get the elimination of C perpendicular. Okay, so क्या किए हमने? This matrix we can take here. So what we did, see, this is C perpendicular in vector form is equal to what? From here we can take, so it is I, j, k, x, y, 0, and 3, 4, 5. It is 3, 4, 5. 3, 4, 5. Okay, and this equal to what? This equal to, we have minus 3.56i plus 0.92 j plus 1.4 k is equal to what? So it's equal to, we have I and then 5y, and 4 is multiplied by 0 here. Okay, that's why 0, and then minus j, and it is multiplied by x is multiplied by 5, so 5x, and 3 is multiplied by 0, that's why 0. Okay, and what about the k? So it is k, and it will be 4x, this is multiplied by this, and 3 is multiplied by 3y, so 3y. Okay, so after this we have to equate this equal to I component of the right side of equation. Okay, then we get the answer. We get what we get? We get, already I have told about this. I have written 0.184 meter, and what about the y component? So it is minus 0.712 meter. Okay, so once again, how we got it? So I'm going to summarize quickly. Okay, so as we have the resultant force, the resultant couple, then we know how to resolve the components means a resultant couple into two parts. So that is C parallel, it is parallel to the resultant force, and C perpendicular, it is perpendicular to the resultant force. Okay, then how to get the scalar component of this parallel couple? Then next, how to get the vector component of the parallel component of the couple. Okay, then how to get the perpendicular component of the resultant couple? Then after that we have to locate from the zero, ठीक है, फ्रॉम द ओरिजिन से कितना शिफ्ट हुआ. सी परपेंडिकुलर को वी आर गोइंग टू नलिफाई. तो नलिफाई करने के लिए क्या कर रहे हैं, दैट लेट्स मूव द रिजल्टेंट टू ए न्यू पोजिशन एक्स एंड वाई. ओके, एंड जेड इज इक्वल टू जीरो. सो ऑलरेडी आई हैव एक्सप्लेन्ड वाई. ठीक है, क्योंकि इसके परपेंडिकुलर आर का परपेंडिकुलर प्लेन लाइज इन एक्स एंड द परपेंडिकुलर टू द couple resultant plane lies in y. Okay, y axis, that's why. Okay, and then after that already we know, suppose there is a position vector and resultant force, so how to multiply through the cross product. Okay, then we have to equate left side, means this left side, left hand side, and the right hand side. Okay, then we got the value of x and y. Then we are left with r and C parallel through this point. So अब क्या हो जाता है, हमारा सिस्टम इज कन्वर्टेड, फोर्स सिस्टम इज कन्वर्टेड इनटू द रेंज. Okay, that is required. With this, thank you.